So section 2.2 is on factoring whole numbers. And so we're going to be taking numbers and we're going to be breaking them down into smaller factors. We're going to be breaking them down into factors that happen to be prime. There's two methods to do these. My favorite is the factor tree method given here. So you can see, for example, let's look at this first chart here. We have a number like 420. We're going to break that down into factors. So we start, I'm just going to do it again over here. We start by asking ourselves, what two numbers could we multiply together to get to 420? And there's many ways to do this, which is why you see 4 rectangles there. But one method I could use is I could say, well, that is 2 times 210, right? You might think, well, that's actually 3 times 140, which means you would do that alternate method. No matter which way you do it, you'll end up with the same result. My 2 is prime, so I'm already done with that branch of my tree. Now I just have to look at my 210. So I ask myself, what two numbers could I multiply to get 210? Well, we could multiply 21 times 10. And now we go further down that branch. 21 still isn't prime, so we need to split that up again. So 2 factors of 21 are 3 and 7. Both of those are prime, so we have gone as far as we need to on our tree on that side. 10, what two factors, or what factors of 10, what two numbers would multiply together to give us 10? That would be 2 and 5. Those are also both prime, so we're now done our tree. And so what we would say is the prime factorization for our number 420 is those prime factors multiplied together. Because if you multiply those numbers together, you'll end up back at 420. Go ahead and try that on your calculator to convince yourself that's true. So let's try another factor tree. So let's say we've got 24. So we would ask ourselves, what two numbers can we multiply together to get 24? And this is where your multiplication sheet comes in really handy. Now, like I said, there's multiple ways to do that, but the first numbers that come to my mind are 6 times 4. So I'm going to write 6 and 4 in there. All right, let's see if we can break that 6 down further. 6 isn't prime, so what two numbers can we multiply together to get to 6? Well, 2 times 3 gives us 6. Those numbers are both prime, so we're done with that branch of the tree. Now we go over to deal with the 4, and 2 times 2 gives us 4. So the way we would write this, if we had been asked for the prime factorization of 24, we would say 24 equals 2 times 3 times 2 times 2. All right, let's try another, 42. Okay, so we're going to start with two numbers that multiply to give us 42. And sometimes students like to even just look at the table and see where you find a 42. The first one I found is for 6 times 7. So we've got a 6 and a 7. 7's already prime, so that branch is done. 6 we can break down to 2 times 3. So we would write this as 42 equals 2 times 3 times 7. Pause the video and try that 48 on your own. Okay, let's do 48 together now. So I'm going to do, and this might be different from what you did, I'm going to say 48 is 6 times 8. 6 can be broken down into 2 and 3. 8 would be 4 times 2. The 2 is already prime, but the 4 we need to break down into 2 times 2. So we would write this as 48 equals 2 times 3 times 2 times 2 times 2. So that's prime factorization using factor trees. There's also another method we can use, which is factoring by division. And I should say, you only need to know one of these methods. So whichever method you find easier, use that one. So factoring by division, so I'm just going to redo this example over here. We would start with our 40 and we make a little grid kind of for it like that. And we think of one number that we could divide 40 by, one prime number. Well, I know 2 divides 40, so I'm going to write 2 here, okay, because 40 is even. Then I would go 40 divided by 2, which gives me 20, so I write that in the line below. And then I think of a number that's divisible, or I think of a number I could divide into 20, a prime number. So 2 also works there. 20 divided by 2 gives me 10. Okay, again, that's an even number, so 2 is a divisor of 10, so I can write a 2 there. 10 divided by 2 gives me 5, and 5 is prime, so I could do 5 divided by 5, which gives me 1. Or we could actually just leave it even here because we know that that 5 is prime on the right. We have got to a prime number. So if we were going to write the prime factorization, it's going to be all the numbers then that appeared on the left column of that table until you were able to reduce your number you started with down to a prime number. So then we would end up like we have over here with 40 equals these 4 numbers here, 2 times 2 times 2 times 5. Okay, same way with the next one. If you look at this next example, so we have 36. We say, well, 36 is even, it's divisible by 2. 36 divided by 2 gives me 18, which you write on the next line there. 18 is also divisible by 2. 18 divided by 2 gives me the 9. 9 I can divide by 3 to get 3. 3 I can divide by 3 to get 1, or actually you can even just leave it right here because you've stopped at the prime number. 3 is prime, so you know you're done. And these numbers here are going to be the factors that make up the prime factorization of that number. Let's do the next one. I prefer to do these on my own, so I'm just going to do it even though it's given there. Okay, 126 is even. That's always a good one to start with. If it's divisible by 2, put your 2 down. 120, oh, is that 6? Yeah, 126 divided by 2 gives us 63. Okay, 63 is divisible by 3. We know that from our divisibility rules because 6 plus 3 equals 9, and 9 is divisible by 3. Okay, 63 divided by 3, I don't know off the top of my head, but we could look at our chart. It doesn't go quite high enough, but it would be 63 divided by 3 gives us 21. You could also use your calculator for that. That would be ideal. Okay, I know 3 is a factor of 21. 21 divided by 3 gives me 7. And 7 is prime, so I can write my 7 here and I'm done. And so these numbers here, we can use as the prime factorization of 126.